Welcome to the deep dive. Today we're taking quite a leap. We're going from one man's really personal story caught up in this huge global shift to something, well, mind-bending about the universe.
That's right. We're exploring that fascinating intersection between cosmonaut Sergei Krikalev's very extended time in space and the physics concept of time dilation.
And our sources for this are basically the info gathered on Krikalev himself and on time dilation as a concept.
Yeah, and the goal here, our mission, if you will, isn't just to list facts. We really want to get under the skin of how Krikalev's, well, unique experience up there, all happening while the Soviet Union was collapsing, how that actually provides a real, tangible example of time dilation, something you can almost touch.
Okay, so let's set the scene then. Sergei Krikalev. He was born in Leningrad back then, a Russian mechanical engineer, and his whole career was basically dedicated to space.
And not just any cosmonaut. We're talking 6 space flights. He's actually 4th on the list for most time spent in space. It's over 803 days.
Incredible,
Right.
803 days. Wow. So his background, he started out in engineering.
Yeah, solid foundation to NPO Energia. He was really hands-on, you know, testing equipment, working out procedures, even doing ground control for some tricky missions. Then he got selected as cosmonaut in '85. That kicked off all the tough training, specifically for long trips on the Mir space station.
Right, Mir. And that's where things got, well, unbelievable. He launched in May 1991. So just try to picture this. You're hundreds of kilometers up, floating, and the country that sent you, the Soviet Union, just dissolves. December 1991, gone.
It's hard to imagine. And what's really remarkable is the massive uncertainty that created for his return trip. Think about it. The launch pads, the landing site, suddenly they're in a different country, a newly independent Kazakhstan.
So how is he even supposed to get back?
Well, that was the problem. This huge geopolitical shift basically stranded him. His mission got stretched way, way out. He ended up spending 311 consecutive days in orbit. That's like double what they originally planned.
Wow. Talk about being stuck between a rock and a hard place. Or rather, Earth and a hard place. So, okay, while Krikalev is dealing with that whole drama, orbiting Earth at what, thousands of miles an hour?
Around 17,500 miles per hour, roughly.
Right, zipping around. The laws of physics are just ticking along, doing their thing. Which brings us to our second big idea, time dilation. Now, for those of us, including me sometimes, who aren't totally up on Einstein, can you give us the clear picture? What is time dilation?
Sure. Basically, it's the idea that time doesn't pass at the same rate for everyone. It depends. It changes based on 2 main things. How fast you're moving relative to someone else, it's special relativity, and also how strong the gravity is where you are, that's general relativity.
Right, so speed and gravity affect time.
Exactly. For Krikalev, orbiting Mir, the main factor we're interested in is the speed, the velocity. Stronger gravity also slows time, but the speed effect was more significant for him up there. The core principle is, the faster you move compared to an observer, the slower your clock ticks relative to that observer's clock.
Slower. My clock ticks slower. Okay. So Krikalev's spending all this extra time, months, orbiting super fast. How does that connect? This is where it gets weird, right?
This is exactly where it connects. Because he was traveling at such a high velocity for, all those extra months, the effects of what we call special relativistic time dilation really started to add up. For him, compared to us down here on Earth, time was passing just a fraction more slowly.
Hold on. You're saying his time, his personal clock, was literally running slower than ours. That sounds like something out of a movie.
It really does sound like sci-fi, doesn't it? But it's real. It's a fundamental consequence of Einstein's special relativity, verified many times. Because of that high orbital speed during his unexpectedly long mission, Sergei Krikalev genuinely experienced measurable time dilation. So when he finally got back to Earth, he was actually physically about 0.02 seconds younger than he would have been if he'd just stayed put down here.
0.02 seconds. Okay, 0.02 seconds. That doesn't sound like very much.
It doesn't. In the grand scheme of a human life, no. It's minuscule. But it's real. It's quantifiable. And that's what makes his story so powerful, I think. It takes this really abstract, theoretical physics concept and gives it a human face, a tangible example. You can point to Krikalev and say, see, it happens.
So it's not just about the amount, it's the fact that it happened at all.
Precisely. And while it seems tiny for one mission, you start thinking, what if someone traveled near light speed for years? The effect would be dramatic. It even makes you question how we define aging or now across space.
Okay, wow. So let's just quickly recap this. We've got Sergei Krikalev basically stranded on Mir while the Soviet Union collapses below him. This means his mission goes on for way longer than planned.
Right, nearly double the time.
And because he's orbiting Earth so fast for all that extra time, he experiences time dilation. He comes back just that tiny bit younger.
That's the core of it, yes. And the why behind it, the science. It comes down to a fundamental rule about the universe. The speed of light in a vacuum is constant. Constant for everyone, no matter how fast they're moving.
Okay.
So for that rule to hold true, something else has to give. And that something is time. Time itself has to adjust depending on your relative motion. Think of it like this, maybe. Imagine bouncing a ball straight up and down while you're running. To you, it just goes up and down. But to someone watching you from the side, the ball travels a longer diagonal path, right?
Okay, I see that.
Light kind of works like that. Because its speed must be constant, if it has to travel a longer path from someone else's perspective, more times have passed for that outside observer compared to the time you experienced. Your moving clock runs slower relative to theirs.
So the constant speed of light forces time to be relative. Huh.
Exactly. And there's maths for it, of course, involving something called the Lorentz factor. We don't need to dive deep into the equations, but the key thing is, the faster you go relative to the speed of light, the bigger this effect, the more time dilation you experience.
So even on the ISS today, moving at, what, 7,700 meters per second?
Yeah, around that speed. Even then, time dilation is happening. It's small, but it's there. Krikalev and actually another cosmonaut, Sergei Krikalev, who also had very long duration flights, they are calculated to have experienced about 20 milliseconds. That's 0.02 seconds of time dilation.
20 milliseconds. 0.02 seconds. Still tiny, but like you said, it's proof. Proof that time isn't just this fixed universal metronome we kind of assume it is.
Absolutely. And it's not just some weird space curiosity either. This stuff has practical impacts down here.
Yeah.
Think about GPS. Your phone, your car's navigation, they rely on signals from satellites.
Right, satellites whizzing around pretty fast.
Exactly. They're moving fast relative to us, and they're in a slightly weaker gravitational field. Both speed and gravity cause time dilation effects. If the GPS system didn't constantly account for both special and general relativistic time dilation, the whole system would fail quickly.
How quickly?
Errors would accumulate so fast that your calculated position would be off by several meters, even kilometers, within just a day or so. It would be useless. So those adjustments are crucial.
Wow, okay. That really brings it home. It's not just theory, it's in our pockets, basically.
It really is. And beyond GPS, the phenomenon itself, time dilation, it's been tested again and again, rigorously. Scientists study fast-moving particles, muons, for example. They're created high up by cosmic rays. They have very short lifespans, but because they travel near light speed, time dilation lets them survive much longer than expected to reach the Earth's surface, just as the theory predicts.
So we see it in particle physics, too.
Yep, and even way back, experiments like the Ives-Stilwell experiment in the 1930s, looking at light from moving atoms, gave early strong evidence. Nowadays, our atomic clocks are so incredibly precise we can actually measure time dilation effects just from moving clocks around in a lab at everyday speeds. It's quite amazing.
The science definitely seems solid. So looping back to Krikalev, it feels like his story is so much more than just, the guy stuck in space during a political meltdown.
Oh, definitely.
He's like a walking, breathing example of Einstein's relativity.
He really is. His experience gives such a human anchor to these huge, sometimes baffling ideas. He wasn't just the last Soviet citizen up there, which is a nickname he sometimes got.
Right, I heard that.
He was also, quite literally, a time traveler, okay? Only by a tiny fraction of a second into his own future relative to us, but still, a time traveler. And it captured people's imaginations.
Right.
There's a documentary, Out of the Present, and even a fictionalized movie, Sergio and Sergei, inspired by his ordeal. It cemented his place, really.
It's an incredible story on so many levels. History, politics, physics, all converging on one person in orbit. So as we kind of wrap up this deep dive, it leaves me thinking, it's a bit philosophical maybe, but if Krikalev traveled even just 0.02 seconds into his future, what does that really mean about time? This idea that time isn't absolute, that it flows differently depending on how you move or where you are in a gravitational field. It sort of messes with your head, doesn't it?
It does. It fundamentally challenges our everyday intuition about time being this constant universal flow. It suggests time is more like a dimension, interwoven with space-time, as Einstein described it. And its passage is relative. Krikalev's story, born from this very specific, dramatic historical moment, becomes this amazing gateway, really. an accessible way for us to start grappling with these profound, counterintuitive ideas from relativity.
Yeah, a human story opening a door to cosmic principles.
Exactly. And hopefully it encourages you, the listener, to maybe dig a little deeper into special and general relativity and look for those other amazing human stories where science and experience intersect.
Definitely food for thought. Thanks for joining us on this deep dive. Until next time, keep asking those big questions.